What if a machine could carry humanity's deepest curiosity across another world? What if silence on a distant planet wasn't empty, but filled with answers, waiting patiently? Millions of kilometers away, a lone explorer wakes beneath a dusty alien sky. Its name is Curiosity Rover, and its mission is extraordinary. It arrived on Mars not as a visitor, but as a relentless seeker of truth. No humans walk beside it, yet it carries the hopes of billions. Every sunrise it witnesses feels both familiar and hauntingly different from Earth. The sky glows with a faint, dusty hue unlike anything we know. The ground beneath its wheels hides secrets buried for billions of years. Imagine waking up where no human has ever stepped before. Imagine relying only on programming, sensors, and distant instructions from Earth. That is the daily reality for this extraordinary robotic explorer. Built by brilliant minds at NASA, Curiosity represents human ambition. It embodies our desire to understand where we came from and where we might go. Every movement it makes is calculated, yet filled with possibility and risk. One wrong turn could damage wheels or instruments beyond repair. Yet stopping is never an option when discovery is at stake. Why would humanity invest so much into exploring a seemingly lifeless world? Because Mars was not always the barren desert we see today. Scientists believe it once held flowing rivers, vast lakes, and maybe oceans. Where there is water, there is always the possibility of life. And where life might have existed, answers about our own origins may lie. Curiosity's mission is not just exploration, but investigation of ancient mysteries. It studies rocks that formed billions of years ago under very different conditions. Each rock sample could reveal a chapter of Mars' forgotten history. Its robotic arm extends carefully, almost like a scientist reaching for evidence. Drills penetrate the surface, collecting samples hidden beneath harsh outer layers. Inside its body, miniaturized laboratories analyze these precious Martian materials. Results are transmitted back to Earth across millions of kilometers of space. Scientists wait anxiously, knowing each message could change everything we understand. But communication is never instant across such unimaginable distances. Signals take several minutes to travel between Earth and Mars. That delay turns every instruction into an act of trust and patience. Curiosity must often act semi-independently, making decisions in real time. It navigates rocky terrain, steep slopes, and unpredictable obstacles alone. Dust storms can suddenly rise, covering solar panels and reducing visibility. Extreme temperatures threaten delicate instruments during freezing Martian nights. Yet despite these challenges, Curiosity continues moving forward without hesitation. Because its mission is greater than any single obstacle it faces. Every image it captures reveals landscapes both alien and strangely familiar. Dry riverbeds stretch across the surface, hinting at a wetter past. Layered rock formations suggest cycles of environmental change over millions of years. These clues slowly piece together the story of an evolving planet, a planet that may have once supported microbial life forms long ago. That possibility fuels every experiment Curiosity performs each day. Its cameras act as our eyes on this distant world. Its sensors feel conditions we cannot physically experience ourselves. Its journey becomes our journey through imagination and scientific discovery. But this mission is not just about Mars alone. It is about understanding planetary evolution across the entire universe. It is about learning whether life exists beyond our fragile blue planet. Each step Curiosity takes brings us closer to those answers. Each discovery raises new questions, deeper and more complex than before. Curiosity does not just explore. It inspires humanity to keep asking why. Why are we here, and are we truly alone in existence? The silence of Mars begins to feel less empty over time, because within that silence, patterns and stories start to emerge. Stories written in stone, dust, and ancient geological formations. Curiosity reads these stories one layer at a time, and with each reading, humanity understands a little more. Yet the deeper it explores, the more mysterious Mars becomes. Every answer leads to even more fascinating unanswered questions. This is the true nature of exploration and discovery, a never-ending pursuit driven by curiosity itself. And this is only the beginning of an extraordinary journey. As curiosity travels further, Mars begins revealing stories hidden for billions of years. Each landscape it crosses feels like turning pages of an ancient planetary book. One day, its cameras capture something that changes everything scientists believed before. A dried riverbed appears, carved deeply into the Martian surface long ago. The patterns resemble rivers once seen flowing freely across Earth's landscapes. This discovery suggests Mars was once warmer, wetter, and possibly life-supporting. Scientists analyzing the data feel a surge of excitement and disbelief simultaneously. Could these formations truly confirm that water once shaped this alien world? Curiosity moves closer, examining rocks smoothed by ancient flowing water currents. The shapes are unmistakable, shaped by movement rather than random formation processes. Evidence begins stacking, each piece strengthening the possibility of past water presence. But water alone does not guarantee life existed there long ago. The rover continues searching for organic molecules within Martian soil samples. Its onboard laboratory carefully analyzes chemical compositions with remarkable precision daily. Tiny traces of carbon-based molecules begin appearing within collected rock samples. These molecules are essential building blocks for life as we understand it. The discovery sparks intense curiosity and cautious optimism among scientists worldwide. However, they remain careful not to jump to premature conclusions too quickly. Mars still holds many mysteries that require patience and deeper investigation. Meanwhile, Curiosity continues its journey toward a massive Martian mountain formation. This towering structure is known as Mount Sharp. Its layers contain a geological timeline stretching back billions of years. Climbing this mountain means uncovering Mars' environmental history layer by layer. Each layer reveals different conditions that existed during various ancient time periods. Lower layers show evidence of wetter conditions, possibly suitable for microbial life. Higher layers indicate a shift toward the dry, harsh environment seen today. This transition fascinates scientists studying climate changes across planetary histories. Curiosity begins its slow ascent, navigating carefully through rocky and uneven terrain. Its wheels endure sharp stones that threaten to tear into their surfaces. Engineers on Earth monitor every movement, ensuring minimal damage during the climb. Despite wear and tear, Curiosity pushes forward with unwavering determination. Every meter climbed represents years of preparation and engineering excellence. As it ascends, the rover captures breathtaking panoramic views of Mars. These images reveal vast plains stretching endlessly beneath a dusty horizon. Dust devils swirl across the landscape, dancing like ghosts of the past. Each scene feels both desolate and strangely beautiful at the same time. But beneath that beauty lies a deeper scientific significance waiting to emerge. Curiosity pauses frequently, conducting experiments at carefully chosen locations. Soil samples from different layers provide clues about chemical changes over time. These clues help scientists understand how Mars lost its water gradually. Some theories suggest the planet's atmosphere slowly thinned over millions of years. Without a thick atmosphere, water could not remain stable on the surface. It either evaporated into space or froze beneath the ground permanently. Curiosity's data supports parts of this theory with compelling evidence. Yet many questions remain unanswered, pushing scientists to dig even deeper. Meanwhile, communication delays continue challenging mission control teams back on Earth. Commands sent today may only execute minutes later on the Martian surface. This delay requires careful planning and trust in the rover's autonomous systems. Curiosity must sometimes decide its own path to avoid unexpected hazards. This independence makes it more than just a machine. It feels almost alive. Every successful maneuver builds confidence in its advanced navigation capabilities, but danger always lurks in the unpredictable Martian environment. One wrong move could trap the rover permanently in soft sand, or damage its wheels beyond the possibility of repair. Despite these risks, Curiosity continues exploring without hesitation or fear, because every moment on Mars is an opportunity that cannot be wasted. Each discovery brings humanity closer to understanding our place in the universe, and each unanswered question fuels the desire to keep exploring further. But just when scientists feel they understand Mars a little better, Curiosity uncovers something that challenges everything. The new data arriving from Mars leaves scientists stunned and deeply intrigued. At first, the readings seem inconsistent, almost like instruments are malfunctioning unexpectedly. But repeated analysis confirms the signals are real and scientifically significant. Curiosity has detected fluctuating levels of methane in the Martian atmosphere. Methane is a gas often linked to biological or geological activity. On Earth, most methane is produced by living organisms or biological processes. This raises an extraordinary and unsettling possibility for scientists everywhere. Could something beneath Mars still be active, even after billions of years? Or is there a non-biological explanation hidden within Martian geology itself? Curiosity begins taking more frequent atmospheric measurements to confirm patterns. The methane levels rise and fall in cycles that seem strangely seasonal. This pattern deepens the mystery rather than providing clear answers immediately. Scientists debate intensely, forming theories and challenging each other's interpretations. Some suggest underground microbes could still exist in protected environments. Others argue geological reactions might be producing methane without any life involved. The debate spreads across the global scientific community rapidly. Each new data set fuels both excitement and cautious skepticism simultaneously. Curiosity continues its work, unaware of the controversy unfolding on Earth. It drills deeper into rocks, searching for additional chemical clues. One particular rock sample reveals complex organic compounds within its structure. These compounds are more intricate than previously discovered on Mars. They hint at chemical processes that may have supported life long ago. The discovery strengthens the argument that Mars was once habitable, but it also raises a deeper, more unsettling question for humanity. If life once existed on Mars, what caused its disappearance entirely? Did the planet lose its atmosphere too quickly for life to adapt? Or did something catastrophic alter its environment beyond recovery? Curiosity's findings begin rewriting our understanding of planetary evolution entirely. Mars is no longer just a dead world in scientific discussions. It becomes a case study of how planets can change dramatically over time. This realization forces scientists to reflect on Earth's own fragile balance. Could similar changes happen here under extreme conditions in the future? The mission now carries a new weight beyond simple exploration. It becomes a warning, a lesson written in Martian dust and stone. Meanwhile, Curiosity faces its own challenges on the surface. Its wheels show increasing signs of wear from sharp rocks. Engineers worry about long-term mobility and mission sustainability. Yet the rover continues moving, driven by purpose and precise programming. Every decision must balance risk with potential scientific reward carefully. Curiosity approaches a new region filled with unusual geological formations. The terrain looks different, almost as if shaped by unknown forces. Rock patterns appear layered in ways scientists did not expect. These formations might hold deeper clues about Mars's ancient environment. Curiosity prepares to analyze this region with heightened focus and care. Instruments are recalibrated to ensure accurate and reliable measurements. Scientists on Earth prepare for another wave of potentially groundbreaking data. Anticipation builds as the rover begins its next series of experiments. Every signal received feels heavier with meaning than before, because now the mission is no longer just about the past. It is about understanding whether Mars could still hold hidden activity today. The idea of present-day processes on Mars changes everything fundamentally. It transforms curiosity into urgency within the scientific community. What if Mars is not entirely dormant as once believed? What if something beneath its surface is still evolving silently? Curiosity continues scanning, measuring, and documenting every possible detail. Its journey becomes more intense, more focused than ever before. Each new reading could confirm or challenge the methane mystery further. Scientists remain divided, yet united by the pursuit of truth. The answers seem close, yet still frustratingly out of reach, and just when clarity feels possible, the mystery deepens once again. Curiosity detects something unusual within the newly explored region. A signal, a pattern, something that does not fit expectations. The data suggests conditions that should not exist on Mars today. Scientists hesitate, knowing the implications could be enormous. Because this next discovery, the new signal arriving from Mars, feels unlike anything recorded before in history. Scientists stare silently, unsure whether excitement or caution should come first now. The pattern appears consistent, repeating under specific environmental conditions across different locations. Curiosity has detected chemical interactions that suggest ongoing subsurface activity beneath Mars. This possibility challenges decades of assumptions about the planet being completely inactive. Could Mars still be evolving quietly beneath its cold, lifeless surface today? The idea sends a wave of shock through the global scientific community instantly. Curiosity is commanded to focus intensely on this unusual region immediately. Every instrument on board begins collecting as much data as possible continuously. The rover's sensors scan temperature, radiation, and chemical composition simultaneously. Results begin forming a pattern that is both fascinating and deeply puzzling. Certain compounds appear only under specific temperature ranges during Martian daytime hours. At night, these compounds disappear almost completely without clear explanation. This cycle repeats, suggesting a process that reacts dynamically with environmental changes. Scientists begin proposing bold theories that stretch the limits of imagination. Some believe underground reservoirs might be releasing gases through tiny fractures. Others consider chemical reactions driven by radiation interacting with buried materials. A few even cautiously suggest microbial life could be influencing these changes. The debate grows intense, fueled by data that refuses simple interpretation. Curiosity continues gathering evidence, unaware of the profound implications unfolding on Earth. Its wheels press deeper into unfamiliar terrain filled with jagged and unstable rocks. Engineers monitor every movement, aware that damage now would be devastating. Yet stopping the mission is not an option at this critical moment. Every second of data could bring humanity closer to a historic breakthrough. The rover positions itself carefully to drill another promising rock sample. The drill engages slowly, penetrating the surface with precise, calculated force. Dust rises briefly, then settles as the sample is secured inside. Inside its laboratory, the analysis begins with extraordinary precision and care. Chemical signatures emerge that align with the unusual atmospheric readings detected earlier. This correlation strengthens the theory of an active subsurface process occurring. Scientists begin connecting patterns across multiple datasets collected over several months. The evidence forms a complex puzzle that is slowly coming together piece by piece. Yet one critical question remains unanswered despite all the progress made. What exactly is driving these changes beneath the Martian surface continuously? The answer could reshape humanity's understanding of life beyond Earth forever. Curiosity continues scanning, moving slightly closer to the most active region. The terrain becomes increasingly difficult, filled with loose soil and hidden traps. One wrong move could immobilize the rover permanently in this harsh environment. Engineers send cautious commands, balancing risk with the need for deeper exploration. The rover advances slowly, each movement carefully calculated and executed flawlessly. New readings begin arriving, more detailed and even more perplexing than before. Temperature fluctuations appear directly linked to chemical variations in the soil. This relationship suggests a responsive system rather than random environmental changes. It feels almost as if Mars is reacting to its surroundings actively. This idea pushes scientists to reconsider everything they once believed about the planet. Could Mars still possess hidden systems functioning beneath its barren exterior? The mission now feels like standing at the edge of a major discovery. Every new piece of data increases both excitement and pressure simultaneously. The world watches closely, waiting for confirmation of something extraordinary. Curiosity prepares for one final experiment in this critical region. Instruments are adjusted to capture the most precise measurements possible. The rover pauses, as if gathering strength for a defining moment ahead. Data collection begins, and signals travel slowly back toward Earth. Scientists hold their breath, watching numbers appear line by line. The results begin forming a pattern unlike anything previously recorded. It confirms the presence of an active process beneath the surface, but the nature of that process remains just out of reach. The discovery feels monumental, yet incomplete at the same time. It opens a door to possibilities humanity has only dreamed about for generations. The evidence suggests Mars still holds secrets far beyond current technological reach. Curiosity has done something remarkable. It has changed the questions humanity asks. No longer asking if Mars was alive, but if something remains hidden today. This shift transforms future missions from exploration into targeted investigation of possibilities. Engineers begin designing new rovers capable of drilling deeper beneath the surface. Future machines may reach places Curiosity could only dream of exploring fully. Plans emerge for returning Martian samples directly back to Earth laboratories someday. These samples could provide answers impossible to uncover through remote analysis alone. Meanwhile, Curiosity continues its journey, still active despite years of harsh conditions. Its endurance becomes a symbol of human persistence and relentless curiosity itself. Each new day on Mars adds another chapter to its incredible story. The rover moves slowly, but every movement carries immense scientific importance forward. Scientists now view Mars as a dynamic system rather than a dead planet. This realization influences how we study other planets across the solar system. Worlds once dismissed may hold hidden activity waiting to be discovered patiently. Curiosity's findings ripple outward, inspiring new missions to distant celestial bodies. The search for life expands beyond Mars to moons like Europa and Enceladus. Humanity's perspective begins shifting from isolation toward possibility across the universe. But exploration comes with responsibility and careful consideration of unknown risks. If life exists elsewhere, even in microbial form, it must be respected. Contamination could destroy fragile ecosystems before we even understand them fully. This awareness shapes how future missions are planned and executed carefully. Meanwhile, Curiosity faces the reality of aging hardware and increasing wear. Its wheels show scars from years of navigating sharp Martian terrain relentlessly. Yet it continues, proving resilience beyond what engineers initially expected. Every signal it sends feels more valuable as time gradually passes. Scientists know its mission will not last forever on that distant world, but its legacy will extend far beyond its operational lifetime. Curiosity has already changed how humanity views exploration and discovery entirely. It has shown that even a machine can inspire wonder and connection deeply. People around the world follow its journey with fascination and emotional investment. Because curiosity represents more than science, it represents human spirit reaching outward. It reminds us that curiosity is one of our most powerful driving forces. Without it, progress would slow and discovery would lose its meaning. The mission proves that asking questions is just as important as answering them, and sometimes questions lead to even greater discoveries than expected originally. As Curiosity continues exploring, new missions prepare quietly in the background. The next generation of explorers will build upon everything Curiosity has uncovered. They will travel farther, dig deeper, and analyze with greater precision. Some may even prepare the way for human footsteps on Mars someday. That possibility no longer feels like distant science fiction anymore. It feels like a future slowly becoming real with each passing year. Curiosity's journey has laid the foundation for that extraordinary possibility. It has turned imagination into a roadmap for future exploration efforts. Yet even with all these advancements, one truth remains constant always. Exploration is never truly finished. It simply evolves into new questions. Mars still holds mysteries that even Curiosity could not fully uncover. Beneath its surface, secrets may remain hidden for generations to come. Waiting for new explorers to continue the story, Curiosity has started. Humanity stands at the edge of a new era of discovery now. An era where distant worlds feel closer than ever before, and where the unknown feels less intimidating and more inviting. Curiosity has shown us that even the smallest discoveries can change everything. It has proven that persistence leads to breakthroughs beyond expectation. And it has reminded us that the universe is far from silent. It speaks through data, patterns, and discoveries waiting to be understood. The question now is not whether we will continue exploring. The question is how far we are willing to go, because the journey beyond Mars is already beginning. In the end, Curiosity is not just a rover anymore. It has become a bridge between Earth and another world. Every signal it sends carries humanity's voice across the void. Every image reflects our desire to understand the unknown universe. Mars is no longer just a distant red dot. It is a place filled with questions waiting for answers. Curiosity's journey reminds us how small yet powerful we are. A single machine changed how we see an entire planet, and it did so one careful step at a time. The rover never asked why it was sent there. It simply continued moving forward without hesitation or fear. That quiet persistence defines the spirit of exploration itself. Humanity built Curiosity, but Curiosity taught humanity something greater. Patience, resilience, and relentless curiosity lead to real discovery. Each rock it studied became part of a larger story, a story written over billions of years in silence. Scientists on Earth continue decoding that silent Martian language. Each discovery reshapes what we believe about planetary life, and every answer leads to even deeper mysteries ahead. That is the nature of true exploration and science. Nothing is ever fully finished or completely understood. Curiosity shows us that even silence can speak volumes. Even dust can hold ancient secrets of existence itself. Mars may look lifeless, but it is far from simple. Beneath its surface may lie stories still untold today, perhaps even remnants of a world once alive long ago, or chemical processes still active in hidden underground systems. The truth remains just out of reach for now, but Curiosity has brought us closer than ever before. It has transformed imagination into measurable scientific reality and turned distant speculation into serious investigation and study. The mission proves that exploration is never wasted effort. Even failures and uncertainties lead to meaningful scientific progress, because every unknown step expands human understanding of existence. Curiosity's legacy will outlive its mechanical body on Mars. Long after it stops moving, its data will continue speaking. Future explorers will build upon everything it discovered there. They will stand on its findings like stepping stones forward, toward deeper exploration of our solar system and beyond. Perhaps one day humans will walk where Curiosity once rolled, and they will trace the same paths across Martian soil, understanding the journey that began with a small robotic explorer. That journey represents something much larger than technology alone. It represents humanity's unbreakable desire to seek truth, no matter how distant or difficult the path may be. Curiosity has shown that exploration is a shared human dream, a dream that connects engineers, scientists, and ordinary people together, across countries, cultures, and generations around the world. We all look up at the same sky with wonder and ask the same timeless question: what else is out there? Mars is just one answer to that endless question, but it is far from the last answer we will find. The universe is vast, waiting patiently for discovery, and curiosity was only the beginning of that journey. The next chapter belongs to those who continue exploring forward, those who refuse to stop asking, what if? Because curiosity is not a machine. It is a human instinct, a force that drives us beyond limits and boundaries. It is what brought us to Mars in the first place, and what will take us even further into space. The red planet taught us to look deeper within ourselves, to value persistence over certainty and questions over comfort, and to never underestimate a small step forward, because even the smallest rover can change the universe of thought, and the story of curiosity is only the beginning of everything.